Hey, 20-1s. Here we are in our next lesson. This one's called geometric sequences. So at this point, we've talked about arithmetic sequences. So a geometric sequence is going to work pretty much the same way. But the slight difference on a geometric sequence is if we're looking at this pattern right here, is we're not adding or subtracting. What we're doing is we're multiplying. So on this one, we're multiplying by 3. So that's what makes it geometric versus an arithmetic. So that's all it is. So this number here that we're multiplying by every single time, this is what we're going to call the ratio. And it's a constant, meaning that it always has to stay the same. So how do we find this? Well, all we do, friends, is sort of the same idea we did with arithmetic sequences. In an arithmetic sequence, if we wanted to find the difference, we would take any term, Tn, and we would subtract the previous. Well, we're going to do the same thing here. So look at this. The ratio of this one, I take any term, but because we're multiplying, the opposite or inverse of multiplication is division. So I'm going to divide the previous term. So 6 divided by 2 is 3. And again, I could take any term I wanted to. 84 divided by 18 is 3. So what's our formula? If we really want to make one, it's any term, Tn, divided by the previous one. Okay, I don't use the formula that much. I mean, you don't need to write it down typically. You just think it's any term divided by the previous. And you will definitely need to use that in here in this section because sometimes the sequences aren't that pretty. Okay, here is your general term or your formula for geometric sequences. And again, I'm not going to prove it to you in these videos. You can always just search them up yourselves, but there it is. And here's how this goes. Well, the good news is we know all these terms already, right? So this is our last term. T1 we know is our first term. And again, if on occasion you see someone might define T1 as A, I might say it every once in a while. I just want you to know A is the first term. R is this new thing here, the ratio. It's what we're multiplying by. And N is the number of terms, right? Now, I always want you to think that we're multiplying. I don't want you to think we're dividing. So if we're getting smaller, I want you to think that our ratio is actually a fraction. Okay, I don't want you to think of this as division. All right, let's see just how much this looks like arithmetic sequences. Just new formula, right? New general term. Okay, if term 1 is 4 and r is equal to a half, determine the general term. Okay, no biggie. So again, always write down your formula or your general term and sub in your values. So T1, well, that's 4. R is a half and minus 1. And really, there it is. However, on occasion, you may be asked to simplify this a little further. So to simplify this, here's what I'm going to do. I'm going to say 4 is really 2 squared. And if I remember back to grade 10, 1/2 is really 2 to the negative 1. And do you notice now we can keep simplifying this down? So what I'm going to do here is I'm going to distribute that negative 1 to both of these. So it'll be negative n plus 1. And now I'm going to multiply these together. So we add the exponents, and I'm going to get negative n plus 3. Why would I want to do that? Okay, I'm quite frankly happy if you stop here. That is the general term. However, what's going to happen every once in a while is either you're going to be asked to simplify, or when you're looking maybe at the textbook or the textbook solutions, they might have done that. And so you're up here saying, but this was my answer. Where did this thing come from? Well, that's more than likely what they did. They simplified it. And you won't always be able to simplify it, but just in case you have to. Okay, there's that one. Let's take a peek at another one here. Determine term 16 for this sequence. Well, first thing I want to identify is that this is geometric. I'm multiplying each term by 3. So it's geometric. Perfect. Write down my general term or my formula. Okay, sub in my values. Well, what am I looking for here? Term 16. Well, T1 is 2. The ratio is 3. Just like that. There's my general term. Maybe I should have done this first. There's my general term. And now I want term 16. So I sub in n is 16. And so I'm going to get 2, 3 to the power of 15. And this is going to be a massive, massive number. I'm just going to stop right there. There it is. Okay, so one of the things you're going to notice with geometric sequences is you're going to get potentially really large numbers because they're growing so quickly. What I'm going to say here is this sequence is going to keep getting, if you think about it, each number is going to get bigger and bigger and bigger. I'm going to say that this grows without bound, meaning it's going to keep larger and larger and larger, that this sequence is growing towards positive infinity. The other term we're going to use later on in the unit is this is divergent. It diverges. Okay, so just a little bit of a preview for some things we'll talk about a little bit later on in the unit, and some terms that you're going to see when you get to calculus, which is a long, long way away, but let's get familiar with those terms now. Okay, number 3. In a geometric sequence, they give us 2 terms, and it says, well, determine the common ratio of the first term and find me the first 4 terms. Okay, so find the common ratio. Well, like, what have I got here? Well, T1, I don't know. Term 2 is -6. Term 3, I don't know. Term 4, I don't know. Term 5, I don't know. Term 6, I don't know. But all of a sudden, down here at term 7, I know this. So I can't figure out the ratio in a rather easy way. I can't just visualize it. Okay, well, again, over my years of math, what I've figured out is if my teacher has given me a formula, I should use it. Okay, I'm still stuck. I don't know what to do, but they gave me this info. So let's figure that out. So for term 2 is equal to -6. What do I know? Well, I don't know term 1. I don't know r, but that's when n is 2. Okay, simplify that down. Well, that's just r to the exponent 1 if you really want to write it. All right, I don't know. That doesn't help me. 1 equation, 2 unknowns. No help. Oh, what about if I tried something with this one? So again, I don't know what I'm doing. Story of my life. But if my teacher says there's a formula, I should maybe use it. So I simplify that down. I get that. Okay, well, that's no help. 2 unknowns. I can't solve for T1 or R. But if I look at the 2 together, now I've got 2 equations, 2 unknowns. So let's put these things together. Now, because it's a geometric sequence, what I'm going to do here is I'm going to divide these things. And it really doesn't matter what you put in the numerator and what you put in the denominator, like how you're going to divide them. Okay, but if you noticed, I put the 192 in the numerator because it's just a larger number. I just don't want to, I want to avoid a fraction if I can, right? It just makes my life easier. Okay, now look what we can do. We can divide. That's going to give us -32. And notice what happens with the T1s. They divide out. T1 divided by T1 is 1. So that's perfect. And if you remember, what I'm going to do here is I'm going to say 6 minus 1. That's 5. We subtract our exponents. Well, now how do I isolate for r? Well, to isolate for r, I'm going to take the 5th root of both sides, or that's the same as saying I'm going to raise each side to the exponent of 1/5. And so I'm going to get r is equal to -2. There's our ratio. And from here, look at everything we can do. If we know R, now we can find T1. So if I want T1, I'm going to sub in R is equal to -2. And again, it doesn't matter which of my two equations I'm going to sub it into, but I think this one's by far the easiest one to sub it into. So T1 is equal to 3. There it is. There's your first term. Then the question said, well, what's your first 4 terms? Okay, well, T1 is 3. The ratio is -2, so I multiply by -2. That's -6. Multiply by -2. That's 12. Multiply by -2, -24. And there's your geometric sequence. If you notice the signs go back and forth between positive, negative, this is known as an alternating series. You might hear that term later on when you get into some higher level mathematics. There it is. Okay, friends, last one. The first term in a geometric sequence is 2. Okay, bingo. Common ratio is 2. If the value of the nth term is 1024, how many terms are there? That's interesting. Okay, so here's what we know. They tell us it's geometric. Teacher tells me, write down my formula or my general term. I don't know what to do. Sub in numbers. Well, Tn is that. T1 is 2. The ratio is 2, and I don't know n. Okay, well, we're down to one equation, one unknown. Okay, more than one way to tackle this. What I'm going to do is I'm going to divide both sides by 2 right off the bat. Just like that. Okay, and now, okay, what am I going to do to solve for n? Okay, I could brute force this out, and I could just sub in values for n in my calculator until I get the answer. But I want to show you something that's really important for 30-1. What I want to do is something we did earlier. I want to turn that 512 into a 2. Well, how do I do that? Because I can't change the value of it. So here's what I'm going to say. I'm going to turn 512 into 2 to the exponent of something. So I need to figure out what this exponent is. Well, I pick up my calculator and I don't know, and I go, 2 to the 6 is 64. No, that's not it. 2 to the 7 is 128. No, that's not it. But 2 to the 8 is 256. We're almost there. 2 to the 9 is going to give us that 512. So I picked up my calculator and I figured it out. And some of you might already have known that. That's cool. And so now, what do I know? How does that help me? Well, look we've got an equation, which means the left-hand side is equal to the right-hand side. I notice that the bases of these are both the same. So if the bases are the same, therefore those exponents have to be equal. And then what's n? Well, n is 10, just like that. Okay, so again, what we did right here, what this is called, is we made this step here. We made the bases the same. Okay, that is a huge skill in 30-1. So if you could practice it a little while you're doing these questions, it's going to help you a lot in 30-1, I promise you. Now, I want to verify my work because on a test, I like to verify my work. So if I want to verify, all I'm going to do is I'm going to sub that 10 back into my equation, just like that. And I want this to be equal to 1024. So 2 to the exponent 9, 512 times 2 is 1024. I verified my work. Okay, friends, there is geometric sequences. Next video, geometric series are coming up.